Our planet is gasping. As Earth battles one catastrophe after another, humankind is looking for a solution. The solution is shining bright in the sky. A periphery that runs for 99 kilometers. Working in it are 3,000 people. The mammoth task will take an array of 2.9 million solar modules, 30,000 metric tons of steel, and more than 5 lakh pile foundation. An equal amount of planning and execution. And more than that, it will take a superhuman effort. With precise engineering and state-of-the-art innovations, a team is striving to achieve the near impossible. A story of hope, determination, and hard work of one of the world's largest solar plants at a single location by an independent power producer. It's the story of rays of change. What is it to look into the eyes of the sun and then keep looking? It is sunshine forever.
The project is so vast that if you look at it, as far as your eyes goes, you can see only solar, solar, and solar.
As the sun shines on the hot sands of Bikaner, a workforce burns to make the near impossible possible. According to Indian cosmology, the universe and humans are made up of 5 elements: space, wind, earth, water, and fire.
So clearly climate change is real. Let's be very clear about this. We have a very urgent and a catastrophe future in front of us. I mean, you see it. Today, it is not even for science to tell us that there is risk in the future.
As Earth faces enormous ecological challenges, humanity is once again looking towards the sun to harness its endless energy, and the aim is to preserve Mother Earth. We have come a long way, and ironically, we are turning back to nature as well. But this time, we humans are technologically advanced and equipped to find a sustainable solution. A gift of God.
Solar is the way ahead. Solar is the future. After all, we are capturing what God has given us, what nature has given us, the power of the sun, and we are using the power of the sun to generate energy.
A solution for humankind. That is what the team is striving to achieve. At a scale that is colossal. And a project getting threatened by a once-in-a-century pandemic. The current produced in the photovoltaic effect in 1883 was minuscule. But here, in Bikaner, at a single location solar plant, they are aiming for a capacity that is one of the biggest. The massive amount of electricity produced is going to be distributed to various Indian states. The Paris Agreement was a landmark international treaty on climate change, aimed to reduce the emission of gases that contribute to global warming. As the world scrambles to achieve the deadlines, India has promised that it will achieve its carbon emission norms by the year 2030.
Very clearly, big solar plants are an integral part of the solar energy, of the renewable energy future that we see.
India is the world's 3rd largest energy-consuming nation after the US and China. The major energy contributor in India's energy production is coal, but it cannot be forever. India will have to rely upon renewable energy sources. Almost every sector of the galloping nation is power-hungry. Development needs power. India is targeting 500 gigawatts of installed renewable energy capacity by 2030. Also, 50% of the country's electricity will come from renewable sources. The challenges are gigantic in nature. Taking this challenge head-on is one man, recognized as the Solar Man of India, Vineet Mittal. Vineet Mittal is the chairman of the company Avaada Group. He was recognized by the industry as the Solar Man of the Year in 2012 and 2014 for his exemplary vision and significant contribution in the field of solar energy.
Avaada is derived from two Indian words, Ayurveda and Vada. Ayurveda is science of life and Vada is promise. So we believe business has higher purpose than just to make profit. A lot of people were skeptical that solar will never become mainstream.
You know, for me, solar is definitely part of the future.
People living in the Indus Valley civilization use sun-dried bricks for their homes, and not very far from this cradle of civilization, an attempt is being made to tap solar energy.
So if you look at in India, Indianness is all about worshipping nature. Our ancestors, us, each of us worship sun as a god. And if you look at scientifically, sun is the source of all form of energy, directly or indirectly.
So we looked at 3-4 major aspects to be considered when we are selecting a project. One is the land availability, second is the evacuation, and third is the connectivity to that location. As far as land is concerned,
We found Rajasthan to be the most appropriate location.
An oasis in the middle of the Thar Desert, Bikaner. Bikaner served as a trade route between Gujarat coast and Central Asia. The historical city is named after the Rajput ruler Rao Bika. The forts, the ornate buildings, the people, the costumes, and the parched sand are all a testimony to the valor of the land. Bikaner, the land of the sun, sand, and camels, has seen many battles, but none like the one that has been waged in the Thar Desert.
and if you talk from any angle, whether it is sizing, whether it is cables, whether it is inverters, this is one of the huge projects which is ever done in the world.
There's not a single country in the world which is not getting affected by climate change. The problems seem to be worsening with time. The need of the hour is to work individually as well as collectively, and the solution is as clear as sunlight.
The future of world lies in how we transition our energy use. And instead of abusing the brown sources of energy, the world needs to move towards the greener sources of energy. If you look at California, they are seeing the drought situation. Even the advanced country like Germany is seeing flood. Closer home in Uttarakhand, we see natural disaster almost every few years.
As we look at solar energy, we are seeing that across the world, the most cost-effective solutions are being provided by the private sector. This is because of the competition. This is because of the ability to draw on the latest technologies and to take risks. Together with the fact that they are capable of raising the resources that are needed for making plants, especially large plants.
Avaada promised one of the biggest solar plants in the world by a single independent power producer at a single location. It needed execution at the scale that was unheard of, a massive landmass to achieve the near impossible.
So there were multiple challenges we faced in land acquisition in Bikaner. It was a Herculean task which was ahead of our team.
It was a stupendous task to bring all the stakeholders together. The boundaries started to grow bigger and bigger. The land started to emerge in the desert.
It was a mammoth task for the team. We had one-to-one meeting with each owner. तो हम लोग एक कंपनी से हैं, अवाडा एनर्जी, और हम लोगों को एक यहाँ पे सोलर प्लांट लगाना है.
An area in the desert, 4,100 acres. The fencing that runs around it is around 100 kilometers. The land acquisition is just the first step. Service contractors and vendors are going to be identified.
The team has gone to take the coordinates at North Point. They had already collected the coordinates for South, East and West. So once they complete the coordinates for North Point, all the corners will be covered.
The equipment is going to be procured and altered to suit the project-specific requirements. The planning is going to be of immeasurable proportions. Every metric is going to be counted and measured. Targets are going to be set and activities defined for all the departments. It is time for the workforce to deliver the grand promise. A project that is going to set benchmarks and contribute significantly to India's pledge of clean energy.
India is the country where the biggest innovations are going to come from.
Avaada is going to make one of the world's largest single-location solar plants by any IPP. The capacity of the solar plant at Kamuthi, Tamil Nadu, India is 648 megawatts. This is going to be a new milestone. Once complete, the plant will have almost 900 megawatts of installed AC capacity or 1,246 megawatts of direct current, benefiting millions of people.
So in terms of this particular project, the size is of importance and the level of complexity which was involved.
Bikaner is in the state of Rajasthan, almost bordering India's territorial boundary. Transporting stuff through a border district of Rajasthan was going to pose significant logistical challenges. The milestone was set. The plan was getting into action. It was time to overcome the challenges and deliver something incomparable in the world. The scale of the project is going to need a substantial effort from the workforce at Avaada.
First, our team is identify the challenges and listed out it. After identify the challenges, we have sit together with our team and micro-level planning was done.
The topological study of the land is the most important aspect of starting a solar plant. The setting of the solar modules can only happen at a defined sea level. All the modules erected are needed to be at the same level, but that was not the case in Bikaner.
Presence of heavy sand dunes in plant area. Due to presence of heavy sand dunes, it is very difficult to start any construction work. Before starting the construction work, we have to level and grade the entire area to start our construction work.
The exuberance to do the near impossible was being stressed by the emerging teething troubles. The desert land in Bikaner posed a strange ground reality. It was uneven. The team met their first tall challenge. This meant more hard work and precise engineering.
It is really a challenging task. So we think innovatively and we deploy tractor dozers. Around 200 number dozers we have employed for 8 months.
To lay the foundation of the solar modules, the team needed to flatten the land, make it all even at the desired sea level.
There is a very interesting thing which has happened. After 1 week of the progress, we saw that there is no progress at all. So we were totally disappointed. Something has got wrong, grossly wrong. So we went back to our office and then sit on the drawing, and then we thought, there is some mistake, and then we come up with a new solution. So what we did, we deployed all the 200 dozers at 2 locations. Earlier, they were deployed at all the locations. So within 15 days, a new thing has happened, that those 2 dunes were totally removed.
To achieve this task, around 200 excavators were mobilized into action. The flattening of hillocks and then the subsequent firming of the land took more than 8 months. After the grading of the land was done, it was time to start digging in the piling structures.
Drilling a hole is not a big deal, but drilling 5 lakh hole is a big deal. So there are around more than 5 lakh drilling. So this is the equipment we used. This is called auger. So this is typically used for drilling.
But the second challenge was lurking around the corner, hiding deep inside. The test drilling was done to check the quality, salinity, and soil-bearing capacity. The soil testing revealed the light-textured, weak-structured, sandy nature of it.
The biggest challenge which we were facing when we were drilling and taking the bit out, soil was collapsing inside. So we again discussed with our team, and then we came up with an innovative solution.
The solution was to pour water into the dry sand before drilling. This was to make sure that its inside walls stayed firm. Sun and sand are in abundance in Bikaner, but water, it is a scarcity. To run a plant of such a massive nature, they needed water. And it couldn't have been brackish water. The salinity in the brackish water would have corroded the steel structures. Even for the construction activity, the plant needed fresh water. But water was nowhere in the vicinity. It was decided to bring in water from a distance of 50 kilometers to the site. An activity that is going to happen every day of the duration of the project. Just another challenge in the progress of the plant. As the drilling gathered pace, it was time to fill in concrete for the foundation. The weather tests had presented another obstacle in the erection of the piling structure: the presence of high-speed winds. Wind direction as well as the speed can seriously affect the production of solar energy. In their pre-engineering tests, the engineers at Avaada had procured the readings of the last 15 years. They themselves did a lot of tests. The readings presented a dusty and ever-present threat. Sudden rush of strong winds or the sandstorms are frequent in the desert of Bikaner. High and persistent winds of more than 50 kilometers per hour can uproot the strongest of the structures from its very foundation. A threat that needed a long-term and permanent solution.
One important thing which we did, that all the outer periphery, those mountain structures are stronger than the inner ones.
More than 5 lakh pile foundations are needed for the 2.9 million solar modules. Module mounting structures bear the solar modules. These 5 lakh four-cornered structures are going to carry the weight of the modules. Avaada needed a structure that was lighter in weight and hence simpler and faster to execute. This innovative structure was fabricated at different locations all over India and then assembled at the site. A strategic and time-bound plan has been made effective. But a multifunctional plan only works when all of its parts are synchronous. As the laying of the foundation for piling structures was in progress, the solar modules started to arrive from different parts of the world.
So in our project, it's the team which actually executes and implements it day in and day out. And as a leader, my responsibility is to facilitate, to ensure that whenever they are struggling, you can motivate them or you can help them in unbundling that problem. So my role is at the bottom of the pyramid, and the team leadership at the site is the one which is at the top of the pyramid, which lives, dream and breathes these projects day in and day out.
A clockwork precision is needed to run the operation smoothly. A single mistake or a delay in a process can result in a cascading effect, resulting in subsequent delays. As the modules started to arrive at the Avaada facility, the piling and the module mounting structures needed to be in place. They were ready. The second major feat has started to take shape. The process of mounting 2.9 million solar modules has started at full throttle. In 1883, a New York inventor, Charles Fritz, created the first solar cell. That was just the beginning of the innovation of the photovoltaic solar panel. That hope has now expanded into unlimited possibilities waiting to catch the sun.
We are fortunate as a nation that we have more than 300 sunny days almost in every part of the country, and we should use that potential of sun to solve energy crisis and transition towards more green and healthier India.
Sun gave us two things. One is light and another is heat. The light component of the sun contains two things. One is the particle of energy, which is popularly known as photon, and another is the heat component. Component of the energy, which is called photon, is absorbed by these solar cells, and this solar cell then emits one electron which is made free to move. And this particular movement of the electron, which is generated by some other process, generates electricity.
The solar modules are needed to be at exact 20 degrees to the sun's position to capture the radiation. The first handshake has been offered to the sun to befriend and harness it. An oasis in the Thar Desert is getting covered in the sea of solar modules.
And in any scale, if you look at it, this is one of the biggest projects.
Almost 2,700 years ago, magnifying glass was being used to concentrate the sun's rays to make fire. The sun's rays were converging at a point to make an immediate fire. Now the sun's rays are tapped to be transported as an electric current to hundreds or even thousands of kilometers away.
We now need a future in which we can secure the energy needs of large numbers of people, and we can do that in a way that we don't blow up the planet.
At the Avaada Bikaner plant, the effort continues. All the empty structures are getting filled by the modules to meet the imposing deadline. The electricity produced at the plant has to be evacuated to the grid for its further distribution. The solar module installation on phase 1 is reaching completion. The civil team will move on to the next phases. The amount of steel used presents a mind-boggling number: 30,000 metric tons.
More than 30,000 metric ton of steel to be used in this project, and which is 3 times the steel that is used in the Eiffel Towers.
To put this into perspective, the largest statue in the world, the Statue of Unity, used 25,000 metric tons of steel. These modules can't just face the sun and not tap it. From the solar modules, the electricity needs to reach the switchyard. It's time for the electrical team to come into the picture.
See, collecting power from such a huge area of 4,000 acres was a major challenge. To collect this power, we have made arrays. From arrays, we have made the junction boxes. From junction boxes, power is coming to the inverters. After inverter, this power is converted into AC. From there, we increase the voltage to a 33 kV system. After 33 kV system, we have connected number of such blocks to make it of a capacity of 25 megawatt.
A solar array is a collection of multiple solar modules. As the modules get connected, it becomes a system, and the arrays generate electricity. There are two wires underneath a single module, one positive and one negative. Once connected, the circuit for the flow of electric current is complete. With millions of modules, the current first needs to be combined from the individual modules before it travels ahead. The string combiner box is used for this job. Current from 30 solar modules travels to a single string combiner box. A string combiner box strings together the output from various modules. It is essentially a monitoring device. It is used to monitor the current, voltage, and total power. 11 such string combiner boxes combine the current further and send it to an individual inverter. The current in household outlets is AC, alternating current. But the current produced by these solar modules is direct current, DC. At the solar plant, it is the job of an inverter to convert DC to AC so that it is made usable for our day-to-day lives. For such a large capacity plant, the plant needed an equal number of inverters. The think tank at Avaada rightly decided that in future, the upkeep, monitoring, and efficiency of the inverters are going to be a worrying issue.
We also did a slight innovation that in this project we had introduced the central inverters as well as string inverters. So we have used a combination of central and string inverters to get the best output from the plant.
After the inverters, the electric current needs cables to travel further. The sand at Bikaner posed a strange situation. The underneath temperature was different from the traditional view. This made the electrical team go for the overground cabling system.
See, making cable overground creates a problem for the movement. But we have used a mix of underground and overground cabling system. When we make the cable above ground, the heat dissipation of the cable is better and the sizing of cable can be reduced.
It's a back-breaking, very slow, and a completely manual task. And when done under the supervision of utmost safety measures, the task becomes all the more tedious.
These high voltage cables are having one inner iron sheath as a covering, which is connected to the earthing system, so that if there is any fault in the cable, the current flows to the ground and the earthing system instead of damaging any property or any human. We have used double insulated cable so that the 200% safety can be guaranteed.
With the sun from above creating a temperature of more than 47 degrees Celsius and burning sand underneath.
Laying of cable in such a vast area was the major challenge. The cables are not trouble-free. The capacity of the cable or the increase in the size of cable in such a large network is also a problem because it creates an ill effect which is called reactive power, and managing that reactive power in such a huge cabling network was an art of engineering.
Because of the cable tray system, the team could facilitate heavy vehicular movement inside the plant without the fear of cables getting destroyed. a very important aspect seen in relation to the fact that hectic simultaneous activities are happening all over the three phases of the plant. Laying cables to the length of 4,700 kilometers is no mean achievement, considering the fact that the whole length of the Indian peninsula from north to south is 3,200 kilometers. So, if the team were to start laying the cable from Bikaner, they would go past the southernmost tip of India, Kanyakumari in Tamil Nadu. But at Avaada, there was no time to revel in the record-breaking accomplishments. Not yet. For the team, it was another battle won in the big war that they were fighting in the Thar Desert. Just when everything is going smoothly, the going gets tougher. A sandstorm that was lurking at the horizon seems to be inching closer. Though at first it decreases the temperature, it brings something else, and loads of it: dust. These blinding sandstorms are frequent in the desert, and they come without a warning. You can only give them a free way. The only way to tackle them is to let them pass. With the completion of module mounting, combining, and the conversion of the current and the cabling, we should be pretty near to transporting it to the grid. No, not yet. The sun is still far. Unless its harnessed energy reaches the grid or to the common man, the war will rage on. All this hard work is not going to mean anything if the switchyard is yet not functional. It was made functional just in time. The switchyard is the heart of a solar plant. If it beats, if it is in rhythm, that only means one thing: the plant is functioning properly. And like in a heart, there are veins and arteries for the in and outflow of the blood. Likewise, a switchyard controls the inflow and the outflow of the electrical energy in a solar plant. The switchyard takes in all the power from the plant and is ready to feed it to the grid. But not before the electricity has been stepped up by the necessary voltage as required by the heavy grid lines. If the switchyard is the heart of the plant, then a transformer is the heart of the heart. SCADA are its eyes and relays are the brains.
This complete monitoring is done by the SCADA system. For this, we have laid huge amount of fiber optic cable. I think 36 kilometer of the fiber optic cable is used in this plant. And this fiber brings complete data to the main control room. From SCADA, the operators see what is happening in each and every corner, whether all the parameters are within their set or the required limit.
All the current coming from the inverters is fed to the transformer for the step-up process. From the transformer, the stepped-up current goes to incoming outgoing panels.
Once power is collected at 33 kV, we increase the voltage to 400 kV by these 7 transformers. And these 7 transformers, once boost the voltage at 400 kV, we collect them in a common bus. Bus means this is something in which all the 7 transformers are connected in a common way. So all the 7 transformers pool power to a particular bus, and from here the power is evacuated to a power grid substation through an overhead transmission line.
But even after the stepped-up current, the most important task is still remaining. A task that has a very small window for completion. A task that is going to be a race against time. A very important part of the end process is the cabling from the plant to the grid. The large high-voltage grid lines carry a massive current, and this creates a heavy magnetic field around the wire. It is just not possible to lay the cable while the grid lines carry the current. They need to be shut for the cabling to be done from the plant to the line. And that means the electricity does not reach a large area. Hence, there's only a small window of 4 hours. Everyone is aware of his responsibilities. The clock is being checked regularly. Just in the nick of time, they have managed to lay the cable, but that's not enough. Once they are finished, everyone needs to be out of harm's way, away from the site, or else it could be life-threatening. Once they make sure that all are safe, the electricity board is informed, the current resumes again. From the grading of the land to the laying of the cables to the grid is one complete circle, like an electrical circuit. The circle is complete. The stage has been set. As the workforce dominate one challenge after another, they are very near to achieving the near impossible. The workforce is jubilant. They are aware that they are well on their way.
Humans have proved time and again that we are able to solve every problem and make a world easier place to live for humanity. So I don't believe in impossible.
By the 3rd century BCE, Greeks and Romans were using light torches. They used to harness solar power through mirrors. The mirrors bounced off the sunlight to light the torches. The torches were then used in religious ceremonies. There's a legend that in 212 BCE, Greek scientist Archimedes used a bronze shield to reflect the focused rays of the sun to burn wooden ships of the enemy. But the time for destruction has long passed. It is time to construct for the future generations. Since centuries, solar energy is being used to cook food. A courtyard, Angan in Hindi, has always been a traditional part of any Indian home layout. The rest of the rooms of the house flank the courtyard. The concept is the same, to harness ample sunlight. From the ancient to the modern, the sun remains the constant.
India has built consensus in partnering countries, and this would be the right way of building the future grid and network. When we have excess energy, it can be used by another nation.
It is the cheapest form of electricity in many, many geographies in the world, but only when the sun is shining. When the sun is not shining, all countries resort to using fossil fuels. This increases emissions. What a transnational grid does is move solar electricity from places where the sun is still shining to places where the sun has already set.
So I think the transnational solar grid is a very grand idea. Essentially, it takes use of the available land resources that we have in the world, where land is available but at lower cost. And therefore, you can put a grid-based solar plant and you can export the energy to places where energy is scarce and land is scarce.
Avaada has a proven track record of commissioning projects that are the biggest. Their already commissioned plants were some of the largest solar plants at the time of completion.
We had done India's largest solar project in the state of Rajasthan. That was a 50 megawatt project. Subsequently, we had done world's second largest project of 150 megawatt in Neemuch in Madhya Pradesh. And we were always dreaming of doing something big in the country and in the world. So that's how we conceived an idea of doing world's largest project in the country.
The Bikaner solar plant is divided into 3 phases. With the successful completion of phase 1 of the plant, they are just on the verge of achieving another milestone. Very soon, the plant will be commissioned and dedicated to the nation. But before that, there is a final check, the final culmination. A last stage signal check to test the stability of the plant. The whole is the sum total of its parts. Every module, every wire, every inverter, the transformer, every nut and bolt and process is checked for its functionality and stability. These tense faces, the wrinkles on the forehead, are waiting for these numbers to stable. These blinking numbers are telling a story of months and months of hard work and planning. It always seems impossible until it is done.
It looks like a dream come true.
Very, very big occasion for the entire Avaada family.
We have done it.
Sandar.
Avaada Bikaner solar plant is going to set new innovation and engineering standards for the world to emulate. A milestone that is going to light the lives. The power produced at the Avaada Bikaner plant is going to travel to various Indian states.
One project is supplying power to MSCDCL. One project is supplying power to Haryana. And the third project is having a PPA with the SECI, which is supplying power to Telangana and Tamil Nadu.
Millions of lives are going to get affected by clean, continuous energy, unleashed by rays of change.
I think our success story has inspired many to invest into the solar. India has become one of the force to reckon with in the solar and clean energy industry, and that's what makes us proud.
Electricity consumption is a precursor to the high socio-economic growth. India seems to be well poised to meet its energy challenges. They dared to look at the sun, and that is what they are about to achieve.